This is a solution video for Text and Test 5, page 138, question 6. In this question, we're talking about population density of people living in a city, and it depends on the radius from the centre of the city. Just note the population is in thousands and the radius is in kilometres from the centre. In part A, they want to know the population density at the centre of the city. That means that we're right in the middle, so we haven't travelled any distance out from the centre, so the radius can be taken to be 0, and we can substitute this into the p equation. This is going to give us a result of 10, but bear in mind that population is measured in thousands in this question, so our actual answer is 10,000. In part B, I want to find the possible values of R, so what are acceptable values for R. Now, what determines this is my value for population, because the population density can't drop below 0. So I want to make sure that the p values that are between the results of the two R values that I calculate will be positive p values. So essentially, if I have my quadratic, which is called p, and my horizontal axis, which is called R, I want to figure out where this function p goes through that R axis. And I can do that by solving the quadratic. Now, in this case, the easiest thing to do is to use the minus b formula, which will be filled in to look like this, and which evaluates to give us two possible solutions, one plus or minus root 6 over 2. But if I have a closer look at this, these two values are not both viable, because the first one, 1 minus root 6 over 2, is actually a negative number. So I need to discard that, noting that R must be greater than 0. So what are my possible range of values then for R? Well, R can be 0 when we have 0 radius, or it can go as far as 1 plus root 6 over 2, because any values between these R's will result in a positive value for population density. Part C says sketch a graph. I'm not going to do that. But if you type that function 10 plus 40x, using x as the variable, minus 20x, use the peak, I think it's over the 6 on the keyboard, into Google search, it'll actually graph it for you. So if you have your graph drawn and you want to check it, that's a nice way to know if you've done it correctly or not. And now I want to calculate Dpdr, which is very straightforward. You're just getting 40 minus 40, or very easy differentiation there. Part E is literally just substitution. You want to evaluate Dpdr at 3 different values of R. So the first comes out as 20, the second comes out as 0, and our third value there comes out as minus 40. And just to put these in a bit of context, it means that when you're half a kilometre out from the city centre, that the population density is increasing at that point, because we've got a positive result for our Dpdr. When you're 1 kilometre from the centre of the city, then Dpdr is 0, so population density isn't changing at that particular point. And when you're 2 kilometres from the centre of the city, the population density is reducing at a rate of minus 40. In part F, they're asking us to find the value of R where the population density is greatest, and hence find the population density for this value of R. Well, when they say look for it where it's greatest, we know that that refers to maximum. So we're going to take our derivative, Dpdr, and we're going to let it equal to 0, and then we're going to solve for R. Now, just to note, we actually don't need to do very much work here at all, because we can look back up to this line in part E and notice that it was actually R equals 1 that gave us a Dpdr of 0, but you can solve it out if you like as well. So R is equal to 1. And of course, note that we're getting a radius here, and radius is a distance, and the units in this case are in kilometres. So let's include that in the answer. And they want us to actually evaluate that maximum density then. So we'll go back to our p function and we'll substitute in our 1, and we get an answer of 30. But again, don't forget population is in thousands. So our population is 30,000 people at that particular radius from the city centre.